Hey, what's going on, folks? It's Mike here, and welcome back to my Deep Programming Language series. In this episode, we are going to take a look at classes again, this time focusing on constructors and destructors. So if you're coming from an object-oriented programming language like Java or C#, or languages like C++ that have object-oriented capabilities, this is going to, again, be relatively familiar to you. So with that said, though, let's go ahead and dive to our favorite webpage for deprogrammers, dlang.org. And we're going to go to documentation, the language reference. I'm going to scroll down a little bit here to classes. And let's go ahead and just take a look at constructors here. So again, constructors are going to be relatively familiar to us because if you've been following this series, you've seen what we've done with structs. And for a class, we do basically the same thing with this keyword. Now, this is really a nice thing, again, in the deprogramming language, that it's just sort of very uniform how we use this for constructor and the tilde mark with this for the destructor, as we're going to see here. And of course, we can change the keyword class to struct as we need. So again, D makes it really easy to refactor our code. But anyways, let's just talk about constructors in case they're new for you or otherwise refresh just a little bit. Then I'll talk about some more interesting things that you can do with constructors just as we go through the spec here. So the main thing is we can define our own constructor for a class. If we don't define one, like if we have a class just like this, and let's go ahead and maybe do some examples here alongside, the D programming language will otherwise generate a constructor for us. It'll give us a default constructor and a default destructor for us to clean up. And it will also give us sort of a default copy constructor as well here. So let's go ahead and create a class here. I'm going to use student as an example here. And as we recalled from the previous lesson, this is a class. So if I want to create a student here, student, let's say Mike equals, I need to allocate it on the heap. So that's the difference with a class, which is a reference type here, which I need to heap allocate. Now, if I want a pointer or something to a student here, and I do something like this, again, this isn't going to be the right syntax. This is what we do for something like a struct if we're going to heap allocate it, okay? So that's something you might get tripped on if you're just new to the deprogramming language. Again, this is a reference type. And if you need a refresher on that, again, check back the previous episode where we talk about this. But this allocates class on the heap as always here. Okay, now let's go ahead and initialize some fields for our student here. Let's go ahead and give our student perhaps an ID. We'll make that an integer value. Let's go ahead and maybe give them a grade. And we can actually provide a default grade. My students are good, so they will get A's by default here. And this will initialize every student with a grade of A here. And this is evaluated at compile time. So again, if you want to provide some initial values here, you can do that. Okay, so no problem here. And let's just go ahead and verify that my grade is passing here. Okay, so I am getting A here, and we can say this is initialized here. But somewhere there is some, code that is constructing this object here. So we call that the constructor. And again, we just use this, which is a special reserved keyword here for our object here. And I'm just going to go ahead and write student constructor called here, just so that we can see that as soon as this object is created, the constructor is implicitly called, right? And that's going to be when we construct this object here with the new keyword here, or the new operator, which allocates a new student and calls the constructor to construct our object. Okay, so that's the basic idea here. And again, we get the same behavior as seen here. Okay, now let's go ahead and scroll down here again a little bit. Now, constructors, again, don't have any return value. So again, they are sort of, we think of them like functions because they're defined in the same way, but really they're just building the object and placing into memory, populating these fields like ID, A, maybe calling some initialization code. So a constructor is not really a function, I suppose, if we really want to get into it. I suppose it depends on how this is implemented in D, but in other languages, we just sort of think of it as here's a set of things that set up the object when I call the constructor, okay? Now, let's get into some more interesting stuff without going too far down that aside here. And we can actually define multiple constructors. So I could define a constructor that does take a parameter. Again, for all intents and purposes, we could just think of it like a sort of special function. Oftentimes we call these special member functions. And maybe I want to set the ID, something like this. And I can say this ID equals ID. And again, when I put this.id, that's referring to the member variable here that's part of this student. And that helps make it less ambiguous. For instance, if I just wanted to call this ID and name the parameter here, right? I could still do that, that's no problem, but that's why we use the this keyword. Now, if I don't use it and it's not ambiguous, so maybe I do something like this here. It might guess, maybe it's doing the right thing, I don't know, but I don't want to really leave it to chance, so that's why I typically use like an underscore or name this something better, because again, this is what you know, the client is going to see, somebody who is using your actual student object here. So anyways, that's just a little aside on that. And then I usually don't explicitly write out this, but again, it can be good to do that as well here. Okay, so anyways, with that in mind, let's go ahead and enhance our example to call this other constructor, in which I'm going to give all of my students an ID of 42. So let's just write out Mike here, and that gives us, okay. Now with this is kind of interesting. It just prints out main.student here. Now, when we did this with our structs, we might have expected like ID and grade to be printed out, because a struct is really just a collection of data here. So that's another thing to kind of just keep an eye out for, again, on some differences between structs and classes. So let's just go ahead and write out these fields, and I'll write them in order here. You might write like a special print function. We could actually also, which might be useful, is write some generative code, right? We've learned a little bit about templates here. Do generate a print function to go over all the fields here. But again, that could be an idea for an exercise for you. So let's just go ahead and do this. And we see, again, 42 and A, because we called the constructor. That's setting up this code here. Okay, so we can explicitly call constructors in that way here. Now, if we want here, we can also indeed use what's called a delegating constructor, which is to say one constructor can actually call another one here. So if I want to use this constructor, which takes one argument like ID, and have it call this constructor, because maybe there's just some initialization code that you don't want to repeat and you want to put it in like sort of this generic constructor to make sure that this is always called, but then again, you can kind of specialize it. You can do this in D, which is really, really nice here. Okay, so you can do this here, and now we'll see student constructor was called. And again, we get the rest of our initialization here from the parameter 42. And then, of course, we're printing this out here. So let me just label this as delegating constructor. There are some rules with this. I believe if I scroll down a little bit, we can see delegating constructors here, meaning that we do need to have some sort of care when we create these delegating constructors. I mean, we don't want to have a cycle. Like, we wouldn't want to recursively call this to like keep reconstructing the object, because then we might get stuck. So that's sort of illegal, or maybe one of these like sort of undefined behaviors, which is totally something reasonable that we, you know, don't want to do. It's reasonable that we wouldn't want to do that. So anyways, those are just some of the rules here. And there's a few other cases here. Like, we really want the construction of our object to, you know, terminate and sort of be deterministic in some way, right? So this is showing an example where it's like, you know, this or something else that's kind of illegal, or so on. So just a few different things to keep an eye on there. Okay, so let's go ahead and label a few of these things with our struct constructors, and then I'll show a few, or excuse me, our class constructors, a few different things here. Again, this is instantiating a class here. Okay, so that's just something that we want to keep in mind when we're doing new here. That is setting up this object. I mean, let's see what happens if we don't use new. Let's do student bad student. No students are bad here, but let's just call this uninitialized student. Okay, we can run this. It works fine. But what if we try to do something with our uninitialized student here? So uninitialized student. Let's try to, you know, access their grade here. Oh, first it's going to give me a little error and says this has no effect, right? This isn't really doing anything. So that's kind of good. The decompiler is pretty smart. It'll give you some warnings about these things here. Let's go ahead and run this here. Segmentation fault. Okay, so we don't like that. And why do we get that? Well, again, as I mentioned, classes need to be instantiated. We need to allocate memory for them. And this is basically a null, you know, object here. Okay, we might as well just say it's equal to null here. And then we could, see why we're getting that segmentation fault. If I may, I'll just remind you, we have a lesson here, lesson 25 on GDB. If we search, there is also one for LLDB if you prefer that as well. So, make sure to take advantage of those lessons if you haven't previously in the series, okay? So anyways, that's just a little bit on instantiation here. Okay, so what I want to talk about next is this ability that if we use an inheritance to say that a student is perhaps derived from another type here. Let's go ahead and set this up. Let's just call this more generically a person. Okay, so a student is a person or like a human being here. And let's say we want to give it, let's give it some attribute like ID here. Okay. And let's actually have a constructor here that can set the ID. Yeah, something like that is fine. ID equals ID underscore here. Okay. And then I can get rid of, well, some of this code here. Because I want to show here, and let's make this just a little bit bigger, how we can also, if we have inheritance here, so meaning a student can be derived from another type and basically inherit all the public properties here, which again, we learned everything is public by default. Then we can make things private or protected. We'll talk about those later on in this series. But I can actually utilize this constructor here when I'm just instantiating my student here. Okay, so what I can do here is I can actually call the superclass here. And let's just go ahead and put in 42, for instance. So let's try to follow the logic here. And what we go ahead and do here is showcase some of the value of what this super thing is doing here. Now I need to use a different number down here. So 55 here. Okay, so let's just kind of walk through and play with this code a little bit here. So, and let's get rid of our uninitialized student here, because that one's not, super interesting right now. In fact, let's just hide it. Actually, let's just leave it commented here. It's a little bit distracting with the highlight. But basically, the idea is we instantiate Mike here. Okay, so which constructor is going to call? It's going to call this one here. We're passing in the value 55. And then, well, we don't really do anything with that value. But then we call this our delegating constructor. And then it's going to go and say, okay, now we want to call the class where we're derived from super, our super class, the one that's sort of above us that we're deriving from. So student is a subclass of person, which we'd call the superclass. And it's going to assign by default an ID of 42 here. Okay, and that's our field here. Now, when we use inheritance, we're also bringing in the attributes here. So you might as well copy and paste ID down at line 11 if you want to think about it that way, but it belongs to person. And because a student is a person, student also inherits that ID attribute. Okay, so let's just go ahead and run this and see what it works. You can make your predictions. What's the ID going to be and what's the grade? And you should see, yes, it is 42 here. Okay, so we do sort of call, all of these constructors that we can see here. Now, what's the power in this here? Okay, let's play around with this a little bit here. And let's go ahead and move super down here. And let's get rid of our delegating constructor for now. Okay, because we're not really doing anything with it here. That's interesting. But we'll call, student constructor is called here. And what's sort of interesting here is if I put super 42 here, and let's actually do something with this ID here, right? Because we are trying to use our student constructor here. And let's set ID equal to ID, just like we had here. And in this example, let's go ahead and rerun it and see what happens, and then we'll go ahead and trace it. If you want to pause and make a guess, you can go ahead and do that. And if you paused, let's go ahead and see. Let's see here. It says, constructor in our derived class for this at line 12. It doesn't have a matching call here, so I need to actually put in a sort of matching constructor here that doesn't take any parameters here, okay? Because that's the one that's going to call here. Or I need to explicitly call. But anyways, so barring that, we have our student here, new student. We pass in 55. So we're using this constructor. We call super 42, which assigns our ID to 42. Then we come down here and we say student constructor is called. And then we do the ID equals ID and so on. Okay. And then it is set to 55 because, well, that's the last thing I did here. I set the 55 or the ID equal to the parameter that I passed in here, 55. Okay. So let's just play around with this order a little bit here. Let's go ahead and now move super below here. Okay. So it'll be the last thing that we do in our construction here. And I'll go ahead and rerun. And as you might imagine, now our ID is printing 42. Because again, if we just sort of trace the code here, we have our student here, I pass in 55, we set the ID to 55, and then we come into our superclass here at the top, passing in 42 here, and we set our ID to 42. That's the last ID that was set, that last value is to 42, so there you go. Okay, so simple enough, you can play around with this. And again, if we hide or don't explicitly call super, let's go ahead and run this. And what's going to happen? Well, we'll be back to 55, okay? Because by default, D is going to place in super here, okay? The call to it, okay? And just to prove that, let's go ahead and put a write line in here. Write line person.this, ID, just so we can kind of see which one's being called here. And let's make sure we know which one's being called. Is it the one with an argument or without? Let's see if it kind of matches. And it's just doing the basic one here, okay? Because it doesn't know, so it picks the most simple one or the default constructor that would be given. And again, that's why we got the error earlier that said, hey, you need to define like this basic constructor here, okay? But you can see that's the first constructor that would be called here in our constructor that we called at line 20 here. At line 21, this is implicitly added here, okay? But, okay, we are free to move this around if needed, okay? And that's a really powerful thing. That's something that's different than perhaps other languages where you call, you're not as restrained, so that's actually a really nice thing. So if this is some like generic initialization code, or it should be called, again, you have a little bit of control over that, okay? So that's actually it with constructors there. Now, the destructor is a little bit more interesting here. So let's go ahead and talk about that. And let's define a destructor. And we do that with a tilde mark and this. And I'm just going to write student destroyed. And let's go ahead and copy this here. And we'll need to write person destroyed. Okay, just to change that message up a little bit here. Okay, so let's go ahead and hide some of this just so we can have our whole window sort of in view here. And see everything that's going on with our program. And let's go ahead and run this. Now, what is a destructor? Well, the destructor is called whenever we either explicitly destroy an object, and we've seen this with structs, or in this case with a class, it's allocated and managed on the heap by the garbage collector. So whenever the garbage collector calls the destroy function, okay? Now we can explicitly call it with classes. That's no problem. Let's go ahead and run this. And we can see, okay, we have our construction. That's the first 2 lines here printed. We print out some of the values here. We get to the end of our program, and our program says, okay, we got to clean up. And it calls all the destructors for us. So student is destroyed because, well, that's the first class that we need to terminate. Then we need to come up to whoever is higher in the hierarchy and destroy that. Okay, so all the destructors will be called here. If you're coming from a C++ background, that means all of these destructors in the C++ world, we make these virtual, and that ensures that all of the destructors are called in both our base class, student, and any classes that were derived from. So that's the important thing for you to see. Every class implicitly does get some destructor created for it, but usually we want to define it for ourselves, especially if we're allocating memory or doing interesting things in our class here. Okay. So with that said, let's go ahead and just peek at our documentation and a few more things here. I'm going to scroll up towards the top here, and I just want to go to our destructors and see if we missed anything here. And again, you can explicitly, just to highlight this, call destroy on an object here. So we could do this, for instance. Let's actually do that. just to show, you have control. You have a little bit of control over these things here, right? Like, let's try to destroy Mike before, we write out this stuff here. And again, let's see what happens. Is that going to cause a problem? That's going to cause a little bit of a problem here, right? It's going to say destroy, destroyed, and then it happens to kind of print out this object with IDs, but it's kind of garbage values here. We can't really, rely on what happened to Mike here. And we can look a little bit closer at this if you want in destroy here. It basically puts the object in, it's not really in a, let's see here. Destroys a given object and optionally resets to initial state here. So if I had allocated some memory in student or something, I believe that's going to put it in some sort of, basically bad state, and we could get a sort of segmentation fault in the same way that we had student uninitialized here. Okay, so you have to be a little bit careful if we're going to do those things manually. You could otherwise do things with like scope, again, if you want to just basically have a little bit more deterministic behavior. We might talk about that a little bit more in a future lesson when we talk about RAII, which is a well-known concept in the C++ world. And again, just having a little bit more control over when we destroy our classes. But otherwise, I think that's all I want to talk about with destructors otherwise. And that is the basic form of a destructor. Again, you can see that it's always virtual, doesn't have any parameters. You only define one, although there could be some other tricks here. I need to think a little bit more about that. Maybe some of you folks have some examples you could provide in the comments of when you'd want to mix in another destructor that could be called. That could be kind of interesting. But I personally haven't run into any use cases where I've done that. So we'll kind of see here. Alrighty, so I think that makes, that's most of what I want to cover here. And otherwise, I do want to point you to one other useful article here. I'll go to the resources, no, I'll go to documentation, articles, and just the C++ to D section, again, just has a little bit of the, like, why you do things in the D way. And again, since we covered this with the calls to super that you can put anywhere here, again, in C++, for instance, you have to do that sort of at the top here, which I suppose is good. That's a uniform way to do it, but it's not as flexible if you do want to move around that the superclass constructor here, or even choose which one's being called or whatever here. So again, you have a lot of freedom with that in the delegating constructor technique. So as always, anyways, we got all the lessons and more here. You can sign up and track your progress for free if you haven't already. All the lessons here that you're seeing on YouTube as of now are being posted to this website here, so feel free to enjoy that. And again, that was a little bit of a monster lesson on constructors. We've still got more to talk about classes as we proceed forward here, because again, we want to have a full coverage, so make sure you stay subscribed for that otherwise. And with that said, folks, I'll look forward to seeing you in the next lesson. And let me know if you've run into any of these interesting use cases, like where you needed to call it destroy or mix in some other destructor. I think those will be interesting to share with the community, some of the edge cases here. But hopefully the fundamentals otherwise are clear. Anyways, folks, with that said, I'll look forward to seeing you in the next one.